had oceans of water. But today, it's almost bone dry.
Venus probably started off with a 3-kilometer layer of water. That's huge in comparison to the 3 centimeters of water that we observe in the atmosphere today.
What makes this all the more curious is that Venus and the Earth drew the material they made of from similar regions in our solar system. And the planets are about the same size. So theoretically, their water content should be about equal too. But it's not. The Earth would have about a 5-kilometer thick layer if you spread its oceans out equally around its surface. Compare that to the 3 centimeters of water that we see in Venus's atmosphere today. When did Venus's evolutionary trajectory diverge from our planets? How did it become so dry and uninhabitable?
Most of the Venus water was probably lost at some point in its ancient history by a fluid process called hydrodynamic escape.
Much of the water in Venus's upper atmosphere was steam. Sunlight split that steam into its hydrogen and oxygen components. Since hydrogen is the simplest atom, it has fewer ways to transform and shed heat. So, as large amounts of hydrogen built up in Venus's atmosphere, the temperature rose, helping atoms attain escape velocity. This sent both hydrogen and oxygen flying into space.
That fluid outflow, though, is kind of self-limiting because it requires hydrogen in the atmosphere to occur. Eventually, the process shuts down.
And so, hydrodynamic outflow doesn't quite explain the parched state the planet is in today. So what does? A team of researchers at University of Colorado Boulder have a possible explanation, a process called HCO plus dissociative recombination.
There's water in the atmosphere of Venus, but most of the atmosphere of Venus is made up of CO2. The water and CO2 both make it into the upper atmosphere.
Sunlight splits carbon dioxide and water to form the electrically charged particle HCO plus. HCO plus recombines with an electron, leaving it with a lot of excess energy.
And so the HCO plus can't remain whole. All of that excess energy that the electron brings in comes out as velocity of the hydrogen atom.
The atom in this state is called hot hydrogen. It's going faster than both the other thermal hydrogen atoms and the escape speed of the planet. And so, the hydrogen atom escapes Venus forever.
For every hydrogen atom that's lost, the atmosphere permanently loses the ability to reassemble a water molecule.
This process isn't unique to Venus. Research shows that about 10% of water lost on Mars occurred through HCO plus dissociative recombination as well. But most of Mars's water loss was thermal. Venus's Earth-like gravity prevents thermal escape, allowing HCO plus dissociative recombination to dominate the water loss process.
Making Venus the best laboratory in the solar system to study these chemical processes that might be important on Venus and Earth and Mars-like planets throughout the universe.